Hi there, Mr. Holcomb here with another episode of The Math Behind the Modules. This is lesson 10, converting repeating decimals to fractions. Okay, so classwork example 1 says there is a fraction with an infinite decimal expansion of 0.81 with the bar over the 8 and the 1, which means they both repeat. It says to find that fraction. So I'm going to let a variable x equal my fraction 0.81 repeating. That's my x. Now, if I multiply both sides by 10, then I get 10 times x on the left, and multiplying by 10 moves the decimal one place to the right. That would give me 8.1818818 repeating. So notice my decimal now, the 8 and the 1's kind of just switched places because of the 8 moving over here. So now let's try multiplying it by 10 times 10, or 100. So we're doing multiples of 10 here, just moving the decimal place. Now that multiplying by 100 would move the decimal 2 places to the right. So that'd be 81.81818181. Whoops. I'm writing 8's over and over, no 1's. And so on, and so on, and so on. Now if I multiply that by 1,000, then I'd get 1, 2, 3 decimal places, or 818.18.1818 is what it would be. Okay, but if you notice x is 0.8181. This is 1818. This is 8181. This is 181818. So when I multiply by 10, here's my x again. So let's focus on multiplying by 100. So isn't this 81 plus my x? Isn't 81 point, here, let me just write equals here. Isn't this 81.81 repeating equal to 81 plus 0.818181, which is, this here is my x. Okay, does everybody see that? X is 0.81 repeating. Well, 81 plus 0.81 repeating is the same as 81 plus x, which is 81 this. So in other words, if we take 100x equals 81 plus x, then we can find out what x is. So to solve this, I would subtract x from both sides. Okay, and I get 99x equals 81. Now if I want to get x by itself, I divide both sides by 99. And the 99's cancel, and I get x to equal 81 over 99. And there is my fraction representation of this repeating decimal. Now I mentioned in an earlier lesson that when you divide by 9, the numerator repeats. So if you have a 2-digit repeat, then it would be divided by 99. If it was 3 digits that repeated, you could say that, well, that's divided by 999. So there's a pattern. Okay, so can this be reduced? That's the next thing I need to look at. Hello, eraser? Can this be reduced? Well, 9 will go into 81 9 times, 9 will go into 99 11 times. So my answer is actually reduced as 9/11ths. Okay, exercises 1 and 2 says, exercise 1, there is a fraction with an infinite decimal expansion of 0.123 repeating. Let x equal 0.123. Explain why looking at 1000x helps us find the fractional representation of x. Well, this is 10th, 100th, 1000th. So if x equals, so I would say if x equals 0.123123 dot 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 forever and ever, then I can say then 1000x equals, that moves the decimal 3 places to the right, 123.123.123, and so on and so on. So that is 123 plus x. So 100x, I'm sorry, that's 1,000. This should have another 0. So 1000x would equal 123 plus x. So then we have x's on both sides and we can solve. So that's why looking for fractions, or looking at it 1000x, will help us find that fraction representation. As soon as we can get the decimal to move over one group of repeats, then we can have an x on both sides and solve. B says, what is x as a fraction? So now they want us to solve this. So 1000x equals 123 plus x. And if I subtract 123 from both sides, no, I'm sorry, if I subtract x from both sides, my fault, then I get 999x equals 123. Then I divide by 999, and these cancel, and I get x equal to 123 over 999. That is reducible. 3 will go into 12 4 times, 3 will go into 3 once, and 3 will go into 999 333 times. So my fraction is 41 over 333. It says, is your answer reasonable? And check your answer using a calculator. Okay, so in answering this, I'd say yes, my answer is reasonable and correct. It is reasonable because the denominator cannot be expressed as a product of 2's and 5's, therefore I know that the fraction must represent an infinite decimal. It is also reasonable because the decimal value is closer to 0 than it is to 1/2, and the fraction 41 over 333 is also closer to 0 than to 1/2. It is correct because the division of 41 over 333 using the calculator is what we started with. So number 2 is the fraction with a decimal expansion of 0.4. Find that fraction. Check your answer using a calculator. Okay, so this should be fairly simple to you now. You let x equal 0.4. So you let x equal that, and it's a tenth, so I'm going to multiply both sides by 10. So that would be 10x equals 4.4, repeating. There's a bar over the 4, so I suppose I should write this. What in the world did my computer just do? Just switch to eraser. Did you see that? Oh my. Now it's all messed up. Okay, let's try that again. 2 more 4's. And then dot, 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 dot. Alright, so this is 4 plus my x. So hopefully you all see that x is 0.4 repeating, so this is an x. So it's 4 plus x. So next step, 10x equals 4 plus x. Subtract x from both sides, and I get 9x equals 4, and divide x by 9, divide x by, or 4 by 9, and I get x equals 4/9. Okay, so if you check your answer with your calculator, I'm not going to do that, but 4 divided by 9 is 0.4 repeating. Okay, example 2 says, could it be that 2.138 with the repeating decimal is also a fraction? Well, let's see. Let's try to multiply it by something that would get us just the repeated decimal as our x, like we've been doing. And so the 1 3 is not repeating, so I need to move the decimal 2 places to the right, so I need to multiply by 100. So if I say, let's see. So let's let x equal 2.138 repeating. So therefore, we would have x equals, let's not put the bar, let's put some 8s. Okay, so if we let x equal that, now let's multiply both sides by 10. So I get 10x equals 21.3888 repeating. And then 100x would equal 213.8888 repeating. And 1000x would equal 2138.8 repeating. Do any of these seem helpful? Okay, so if we focus on something, if we move it, like I said, over to just the repeating decimal being our fraction that we're trying to find, then we could let, if we know that 0.888 is so if we know that 0.88 repeating equals some fraction a over b, we don't know the numerator or the denominator, but we know it's some fraction a over b, then we can use this equation right here, and let's that equal y. So then we can say y equals 0.8 repeating. 10y equals 8.8 repeating. So 10y equals 8 plus 0.8 repeating. So if I now see that y is 0.8 repeating, now I can say 10y equals 8 plus y. And if I subtract y from both sides, then I get 9y equals 8, and divide by 9, then I get y equals 8/9. So now I know that my y is 8 over 9. So my a is 8, my b is 9 that I was looking for. Okay, so what's good is that? Okay, so now I'm going to go up to this now, and I know that that is 100x plus, or equals, 100x equals 213 y. First, let me write it like that. 100x equals 213 y. Well, y is 8/9. So 100x equals 213 and 8/9. So if I do what I did in our last video or a couple of videos back, and I know that this is plus 213 plus 8/9, so I can represent 213 as 213 times 9 divided by 9 plus 8 divided by 9. So 100x equals These 9's cancel, and I get 213, or no, I multiply them. 9 times 3 is 27. 9 plus 2 is 11. 9 times 2 is 18, plus 1 is 19. Now I have 1,917 over 9 plus 8 over 9. So now I have 100x equals 1,925 over 9. Okay, just a little tedious, but we're getting there. So what do I want to do here? Well, I want to solve for x. So I'm going to divide both sides by 100, which is the same as multiplying by 1 over 100. So this is gone, and I get x equals 1,925 divided by 100. That will reduce, because they both end in 5. And, oh, that's 900, by the way. But they still reduce. So let me think here. Well, let's just reduce it. We can reduce it by a factor of 25, since it ends in 25 here, and 25 will go into 900. There's 4 25s in 100, so there's 36 in 900. And 1,925 divided by 25 is, 25 will go into 192 7 times. And 75, 85, 92, let me think here, 75. And that's a 7 as well. Sorry for that distraction there. So it reduces to 77 over 36. If I put that in my calculator, I should get 2.138. Okay, so let's try that again. And we're just going to repeat the process, and hopefully you'll get the hang of it after a few of these. So it says to find the fraction equal to 1.623. Check your answer using a calculator. So you let x equal the whole thing. And you let y equal the repeated portion. Okay, so ignoring the 1 and the 6. So you say 0.23 would be our y. Okay, so if x is 1.623 repeating, then 10x is 16.23 repeating. So I just want to move the decimal over until I get y to the right of my decimal. So I multiplied both sides by 10, okay, to get a number plus y. So now I need to find the value of y. All right, so this is 100ths. So 100y equals 23.23 repeating. So 100y equals 23 plus y. Okay, that's the key to this problem. This step right here, you have to understand that if I multiply y by 100, I get 23.23 repeating, and the 0.23 repeating is y, so 23.23 repeating is 23 plus my 0.23 repeating, or plus y. Now I'm going to subtract y from both sides. And every time I do this, I'm going to get the same value. I'm going to get 99y equals 23. Okay, divide by 99, and I get y equal to 23 over 99. Okay, so let me just see if I can move all this over. Okay, so now our final step is put this all together. So 10x equals We're using this now. 10x equals 16.23 repeating. So 10x equals 16 plus y. Well, my y is 23/99. So 10x equals 16 plus 23/99. So I'm going to multiply 16 by 99/99, which is 1. So I can do that legally. 16 times 99 divided by 99 is the same as saying 16. So I'm going to leave this piece alone. So 10x equals, hey Siri, what's 99 times 16? I already know, it's 144.
99 times 16 is 1,584.
1,584 over 99 plus 23/99. So when I combine those, I get 10x equals 4 plus 3 is 7, 8 plus 2 is 10, carry the 1, 5 plus 2 is 7, plus 1 is 8. I get 1,000, did I do that right? No, not 8. 6. So 4 plus 3 is 7. 8 and 2 is 10, carry 1, 5 plus 1 is 6. 1,607 over 99. Okay, so I'm going to divide both sides or multiply both sides by a tenth, depending on how you look at that. These cancel. I get x equals 1607 over 990. So that means 1.623 with the repeating decimal equals 1,607 over 990. And you can always check that with your calculator. Okay, number 4 says to find the fraction equation to 2.960. So you let x equal 2.960, where the 60 keeps repeating. You let y equal 0.60 repeating. Okay. I only need to move the decimal one place to get the repeating portion to the right of the decimal by itself, so I need to multiply both sides by 10. So 10x equals 29.60 repeating. So if I let y equal 0.60 repeating, and I want to get the decimal over here so it's a number times the next repeated portion, I need to multiply by 100. I need to move the decimal 2 places to the right. So I'm going to multiply both sides by 100. So I get 100y equals 60.60 repeating. Well, that means that 100y equals 60 plus y. So when I subtract y from both sides, I get 99y equals 60, and then I divide by 99, then y equals, now I can reduce this by 3. 3 will go into 60 20 times, 3 will go into 99 33 times. So y equals 20 over 33. Now I'm going to take my original equation of 10x equals 29.60 repeating, and I'm going to substitute in my givens now. So that is 29 plus y, so this is my y, so this is 29 plus y, so 10x equals 29 plus 20 over 33. Now this denominator is going to get multiplied by 29, so I have to multiply it by 33 over 33. So 10x equals 29 times 33 over 33 plus 20 over 33. So 10x equals, hey Siri, what's 29 times 33?
29 times 33 is 957.
So that's 957 over 33 plus 20 over 33. So 10x equals 957 plus 20 is 977 over 33. Multiply both sides by a tenth. And these cancel, and I get x equals 977 over 330. And that does not reduce. So that means, therefore, 2.960 repeating equals 977 over 330. Okay, that is the end of lesson 10. Review the lesson summary, which gives you an example, and go do your problem set.